This video is based on my observations on captured wireless frames on one UniFi access point and two Wi-Fi client only. If you see anything wrong in the video, please let me know in the comments. MLO stands for multi-link operation. For UniFi Wi-Fi 7 access points, it's a long-expected feature. Finally, Ubiquiti released it in the official firmware. In this video, we will discuss how MLO works in UniFi Wi-Fi 7 access points, and we will see it in action about whether or how the enhanced multi-link single radio can help the client's Wi-Fi activities. Then we will use Wireshark to understand how the Wi-Fi client interact with the two radio bands in MLO mode. A lot of things to discuss. Let's get started. At this moment, Ubiquiti's E7 doesn't have the updated firmware to support MLO yet. So I'm going to use a U7-Pro-Max for this video. In UniFi Network Controller, if I go to this access point, go to settings, you can see for all the three Wi-Fi bands, I have already set the channel width to the widest one. Then for channel, I set them all to auto. That's the simple setting for the access point itself. Then if I go to Wi-Fi SSID setting, I only have one SSID, and at this moment, all the three Wi-Fi bands are enabled, and I also have the MLO enabled. Of course, because I enabled MLO, you can see for the security protocol, you have to select either WPA3 personal or enterprise. That's the prerequisite to use MLO. Then in the lower part, for this window, I use a Intel BE200 Wi-Fi chip. It supports Wi-Fi 7, support MLO. If I try to connect to this SSID X1, let's see what's the result. For this X1, let me click on connect. Okay, it's connected from the Windows 11 machine. If I go to the connected SSID's properties, I can see, yes, protocol is Wi-Fi 7, and for network bands, you can see it lists out two Wi-Fi bands, 6G and 5G Hz, and it has the aggregated link speed listed here. This time, I'm lucky because the system automatically chose 5G Hz and 6G Hz. But in my offline testings, most of the time, the system will choose 2.4 GHz and 5 GHz. Just for consistent testing for this video, let me make a change to this SSID. Let me remove 2.4 GHz so that I can make sure I always use 5G and 6 GHz. And hold your thought. You may think, why you disable 2.4? Why not enable all three of them so that your client can use all three Wi-Fi bands, right? We will talk about that later. Because the SSID's configuration is changed, here I need to reconnect to X1. Click on connect. Okay, it's connected again. For property, of course, it's showing the same information as previously. And if I go to UniFi Network Controller for client devices for this particular Windows machine, see, if you compare to regular non-MLO client, they will only have one Wi-Fi band listed here, right? But for this Windows machine, it lists out two Wi-Fi bands. There's one thing I want to mention, is about the signal strength for each Wi-Fi band. You already saw the change when I just show you the screen. Both are showing green color, right? But now the 6 GHz is showing ridiculously weak signal strength. In fact, I put the Windows machine very close to the access point. So for both Wi-Fi bands, the signal strength should be very strong. But here is showing the red color. My understanding is it's because of the method Ubiquiti used to implement MLO. Currently, the 6 GHz Wi-Fi band is not actively monitored by the AP and by the client. So that's why here it's just showing this lowest possible signal strength. And then if you continue looking about the information, you can find out this about standard. So for regular Wi-Fi 7 client, non-MLO ones, you will only see Wi-Fi 7. But here you see it says .mlo. This confirms, yes, now the Windows machine is using the MLO to connect to the access point. But no matter how hard you look into the network controller, you cannot find out what is the MLO type used by Ubiquiti for this access point, and you don't know how the client is using the two Wi-Fi bands together to achieve the network traffic. That's the focus point for this video. We will see behind the screen how the MLO really works for Ubiquiti access point. In this slide, I put the 3 different ways to establish link between AP and your Wi-Fi client. So the first one, that's the regular way. So you have a Wi-Fi device which doesn't support MLO. When it's on air, it need to choose a Wi-Fi band. Then use that one to connect to the AP. It cannot connect to the AP using multiple Wi-Fi bands. That's the way we are super familiar with. Then in the middle, that's the ideal way. When it's the first time you heard of the concept of MLO, you may think, okay, perfect. So my Wi-Fi device can connect to the 3 Wi-Fi bands of the AP. I can aggregate the bandwidth from 3 Wi-Fi bands. But in real world, for UniFi AP, unfortunately, it may not work in the middle way. It works in the lower part way. Before the connection happens, the Wi-Fi client has choice to establish connections with 2 Wi-Fi bands. But during runtime, it can only use 1 Wi-Fi band to do the communication at a given time. If you go to this very helpful document from Intel, you can see Intel listed out multiple MLO types. The first one is called multi-link single radio, the receiving and transmitting over 1 link at a given time. Then the second one is EMLSR, which is still using 1 radio at a given time, but it has additional capabilities to listen to 2 links at the same time. But keep in mind, it can only use 1 radio to do the real Wi-Fi traffic. The first 2 are SR, single radio. Then the remaining 3, they are MR, multi-radio. They can achieve the effect, as I show you in previous slide, the aggregated bandwidth from multiple Wi-Fi bands. However, from Ubiquiti, I cannot find any document mentioning MLO type supported by Ubiquiti access points. From this so-called document from Ubiquiti, you can see almost useless information about MLO. But I'm really interested to know how it works in UniFi AP when it comes to MLO. So the only way left for me is to dig into the system, use Wireshark, use SSH, try to find some information, if any. This is what I'm going to do. As you can see, this Windows machine is connected using MLO, using 2 Wi-Fi bands, 5 GHz and 6 GHz. So in the left side, I have 2 Mac Minis. The top one is a M1 Mac Mini. I'm going to use it to run sniffer to capture 5 GHz Wi-Fi frames. And for the lower part one is a Mac Mini M2. It supports Wi-Fi 6E, so it does support 6 GHz Wi-Fi band. So I'm going to use it to run sniffer to capture 6 GHz Wi-Fi frames. Yes, the lower part M2, it doesn't support Wi-Fi 7, but it doesn't matter because I'm not using it as a Wi-Fi 7 client. I'm simply using it to capture Wi-Fi frames for 6 GHz Wi-Fi band. Okay, just to clarify it. So now I'm ready to do the capturing. From the client information in UniFi Network Controller, you can see for 5 GHz, the channel is 100. So in the sniffer, let me choose 5 GHz. 100 channel, and then for width, let me choose the widest possible one. Then for the lower part, Wi-Fi 6, let me choose channel 117 for 6 GHz. Then the widest possible width, 160. Okay, then from the Windows machine, let me first disconnect it from the SSID. Okay, what I'm going to capture is to understand how the Windows client connect to the two Wi-Fi bands using MLO. I'm ready. I need to start capturing in the two Mac Mini. Start it. Okay, and start the 6 GHz. Okay, started. Then from the Windows machine, let me click the connect button. Okay, it's connected. Then let me disconnect. Okay, I have done one cycle to connect and then disconnect, right? I should have the Wi-Fi frames I need for both Wi-Fi bands. Let me stop capturing. Okay, I have opened the captured frames using Wireshark in the two Mac Minis. You may notice I already have some filters just to show the frames which we are interested in each Wi-Fi band. For now, bear with me. Later, I will explain why I added these filters and where they come from. So you can see in the beginning, we see a whole bunch of beacon frames, right? Which is sent out by the UniFi access point. And from these beacon frames, we can already know what type of MLO is supported by the AP. For the 6 GHz Wi-Fi band, let me pick a random one. Let's say the very first one. They are all the same. Then I go to the very last section, wireless management. Then go to the second one, tagged parameters. Then go to this particular one, multi-link. This is for MLO. Okay, let me expand the common info. And here under the EML, which means enhanced multi-link, see in the Intel document, you can see the second type is called EML-SR, right? Which is Enhanced Multi-Link Single Radio. So let's see what type of MLO is supported by this AP. Expand EML. See, U7-Pro-Max supports and only supports EML-SR. For the more advanced, the multi-radio MLO type, no, they are not supported. So now we got our answer about the MLO type already. Let's see a additional information if I expand the MLD capability. MLD means multi-link devices. See the very first, it says maximum number of simultaneous link is 1. For the AP, it sets this field to the number of its supported affiliated AP's links minus 1, which means the AP itself support 2 here. So this value is a little bit confusing. It has a minus 1 in the formula. This is for 6 GHz, right? For 5 GHz, it's also broadcasting the beacon frame. Let's check the frame in 5G as well. Expand it to the same section. For EML capability, yes, it's EML-SR only. And then for MLD, yes, it only supports 1 simultaneous links. So it's the same capacity announcement from the AP in different Wi-Fi bands, right? Now we have a good starting point because as long as we know what's the MLO type supported by the AP, we can have more targeted testing to see how it works. We just checked from the captured wireless frame about the AP's capability when it comes to MLO. In fact, in the communication between AP and station, the station side or your Wi-Fi client side is equally important. Maybe it's even more complicated than AP. The reason is there are so many different Wi-Fi clients. They have different capabilities. In the lower right, in this author's article regarding another vendor's AP, the author listed out the device capabilities. You can see for the Intel BE200, which I'm going to use in this video, it only supports EML-SR. It doesn't support any multi-radio MLO types, for example STR, even if the AP supports it. Then here it says for Qualcomm Wi-Fi7 adapter, it does support STR, ML, MR. I have ordered a Qualcomm adapter, but I haven't received it yet. So in this video, I can only use Intel BE200 for the testing. And then I'm also going to use iPhone 16. And you can see iPhone 16 is not listed out in this author's article. So let's find it out what's iPhone's capability when it comes to MLO. In the captured frames, before the four-way handshakes, there should be a association or reassociation request from the Wi-Fi client to the AP. For example, here for the 5G captured frames, you can see before this four-way handshakes, the blue color one, there is this one, reassociation request. It is sent from my Windows machine to UniFi AP. If I check the details, go to the same section, MLO capability. You can see under the EML capability, it only supports EML-SR. It doesn't support EML-MR, right? And then under the MLD capability, you can see for the maximum number of simultaneous links, it says 0. Remember for the AP, we see 1 here, right? Then for the 6 GHz captured frames, for this one, association request, let's check the same section. The same thing, it only supports EML-SR, and maximum number of simultaneous links is 0. For a non-AP, meaning station Wi-Fi client, if it only has single radio, it should set this field to 1 minus 1, which is 0. So remember for AP, we see 1, right? 1 means the AP supports 2 simultaneous links. Okay, so this field is a little bit confusing, but that's how the value is set. Because currently I don't have a client device which supports multi-link, multi-radio, so I cannot confirm or validate whether the UniFi AP supports STR, ML, MR. So in this video, we are only going to explore the support for multi-link single radio. EML-SR, the enhanced multi-link single radio, is supported by both the AP and the client in this video, right? Then let's focus on it. This MLO type can dynamically steer across multiple links. So the client can split its RX chains to listen on 2 links simultaneously and then switch all the chains to 1 link dynamically. Because it allows the client to listen on 2 links simultaneously, it will increase the chances of successfully receiving data from multiple sources. And the ability to dynamically switch all chains to 1 link can enhance the flexibility and ensure optimal link utilization based on current network conditions. And by listening on multiple links, the EML-SR reduces the possibility of missed transmissions. It may improve the reliability of data reception. So a lot of seemingly potential benefits, right? Let's see MLO works in action in my lab environment. Now I have connected 3 Wi-Fi clients to the same SSID. So the Mac Mini M1 only supports Wi-Fi 6, so it can only connect to 5 GHz. And then for Mac Mini M2, it supports Wi-Fi 6E. It does support both 5 GHz and 6 GHz, right? But from the network controller, for this Mac Mini M2, I can see now it is connected to 6 GHz. Then for this Windows machine, it uses Intel BE200 Wi-Fi card. You can see now it's connected to both 5 GHz and 6 GHz. And for both Wi-Fi bands, the color is green. So just from this UniFi network controller, I cannot tell which one the Windows machine is actively using for traffic. So we will find it out. Then in the lower part screen, for the Linux virtual machine, I already launched 3 separate iPerf3 servers. They are listening to different parts so that later I can run at most 3 iPerf3 sessions. The reason I need this Mac Mini computers is I don't know which Wi-Fi band the Windows machine will be using, right? So depending on which one it will be using, I will use the corresponding Mac Mini to add more traffic to that particular Wi-Fi band, and hoping the Windows machine can automatically switch to the other Wi-Fi band because the Wi-Fi chip does support MLO, right? Let's see whether I can achieve the goal. So from this Windows machine, let me run iPerf 3 in client mode, run it for a long time using bi-direction, which means both upload and download, and then use 10 parallel connections. So I really want to saturate the bandwidth the Windows machine will be using. So let me start it. Okay, then from the speed, it seems it's using 6 GHz, but let's validate it. Let me go to UniFi network controller. For U7-Pro-Max, go to Radio Manager, then go to Environment. You may know this access point supports the spectrum analyzer, so we can see the different Wi-Fi bands traffic in real time in both waveform and waterfall fashion. So let me go to 6 GHz first. Yes, it confirms. See, with the 101 channel as the center, this area is showing red color, which means it's very busy now, right? Then if I go to 5 GHz, yeah, you can see for the channel 149 and close area, it's showing green color, so there's no traffic here. We just confirm, yes, the system is using 6 GHz now. Then let me add more traffic to 6 GHz. The purpose is to add interference to the Windows machine's traffic, hoping the MLO functionality will automatically switch to 5 GHz because there's no traffic there, right? Let me try it. So from the Mac Mini M2, which will be connecting to 6 GHz, let me start the iPerf 3 testing. Okay, start it. Yeah, you can see the Windows machine's speed is reduced. Then you see the sudden change in the spectrum analyzer. So in this area, the width is 80 megahertz. It's showing dark red, which means the Windows machine automatically switched to 5 GHz already. So that's why from this Mac Mini M2, you can see it has a pretty good speed now. And then the Windows machine, the speed is also not bad. You see the MLO's effect in action, right? Even though Intel BE200 Wi-Fi chip only support EML-SR, single radio, you can still get the benefit, which is the system can smartly detect which channel will have better traffic, so it will automatically switch to that, thanks to MLO. Okay? The next topic is also what I'm very interested in. It's about MAC addresses used in MLO. So you may know for a access point, of course, the device itself has a MAC address, right? But to provide Wi-Fi services in different Wi-Fi bands for each SSID, the AP needs a dedicated MAC address, different than the device MAC address itself. And then for the client to communicate with the AP, it also needs MAC address. When it comes to MLO, there's a thing called MLD MAC address. MLD stands for multi-link device. That MAC address is unique, special in the MLO communication. But just from UniFi network controller, yes, of course, you can get the MAC address for the AP itself, but nothing else. So to find it out, what are the respective MAC addresses in different situations, let me SSH into the access point. In the lower left, let me SSH to the U7-Pro-Max. Okay, I'm in. Run command iwdev. I will list all the devices which are associated with different SSIDs. So there are a lot of devices existing in the access point, but the very last physical device catches my eye. The name, it starts with MLD, multi-link device, which means this device is related to MLO functionality of this access point. And see here, it has a address. So we already get the MAC address, which is associated with MLO. If we continue looking, there are different interfaces for different SSIDs, right? We only have one SSID, which is X1, and it is broadcasting using 5G and 6 GHz. I do have two other devices I'm interested in. In my current configuration, ATH0, it is for 5 GHz, and here I can find the MAC address for its regular AP functionality. You can see there is a additional MAC address. It's labeled as MLD MAC address. This is the one I want to find out. So you can see it's slightly different. And then if we continue looking, we can find this ATH2. The channel 101, the frequency is in 6 GHz and the SSID is X1. So ATH2 is for our 6 GHz SSID. Yes, this is the MAC address for 6 GHz, and similarly here it lists out the MLD address. You can see this one is exactly the same as the 5G one. I've listed all the findings in the diagram, so you can see no matter which Wi-Fi band, the MLD MAC address is the same. It is the device MAC address of this UniFi AP. And then, of course, for each Wi-Fi band, it has its own MAC address. But we still need to understand what's the situation for the client for this BE200 Wi-Fi chip. So in the lower right, in the previously captured 6 GHz Wi-Fi frames, let me use, for example, this green color, this association request as an example, because it's association request. So it's sent from the station to the AP. That's why here for source, you see it ends with E2, which is the hardware MAC address of this Wi-Fi chip. And the destination ends with 79. If you compare with the diagram, you can see it's the AP's 6 GHz MAC address. That makes sense, right? Then if we go to the frame details under wireless management, tagged parameters, under multi-link, under common info, here we can see another MAC address. It's labeled as MLD MAC address because this frame is from the client to the AP. So this MLD MAC address is for the client, for the Intel Wi-Fi chip. I noted down this MAC address in the diagram as well. So we just found out what's the MLD MAC address for the client, right? So then let me check another frame, for example, this association response, which is sent from the AP back to the client. If we just check the frame itself, the source ends with 79, which is the 6 GHz AP's MAC address. Destination ends with E2, which is the hardware MAC address of the Wi-Fi chip for the client. And if we go to the same section for the wireless management section, yeah, we can confirm the MLD MAC address for the UniFi AP is this one, the same as what we note down in the diagram. In the Wi-Fi communications, in different scenarios, the AP or the Wi-Fi client will use different MAC addresses to do the communications. Based on the current filter, what I said is I want to see the frames which are related to the 6 GHz MAC address and the MLD MAC address. So you can see different frames, what MAC address is used. For example, for the beacon frame, it's using the 6 GHz MAC address. For the four-way handshake during authentication, it's using the MLD MAC address. And for this data frame, it's using the MLD MAC address. And for a MLO client, to tell the AP whether it want to make the link active or in sleep mode, it will send the AP a QoS data or null frame. Inside the frame, there will be a indicator. So let me find such an example. Yes, here I see several QoS now frames sent from the client to the AP, right? Let me pick this one. Under the QoS now section, see there's a frame control, right? There is a flag section. Yes, this flag is called power management. Current value, it's 1. 1 means, okay, the station, the client tells the AP, okay, even though now this link is between you and me, I will go to sleep. That's how the client tells the AP whether it wants to use this link at this moment. And you can see for this particular frame, it's sent using the MAC address of the client to the MLD MAC address of the AP. Okay, and you can see for this blue four-way handshakes, it's also between the AP's MLD MAC address and the client's MAC address. Okay, it's too detailed, so I want to end here regarding MAC address discussion. Let's move on to the very last section, which is about iPhone 16 and this particular UniFi access point. The reason I want to test iPhone 16 is I know iPhone 16 claims to support Wi-Fi 7 MLO, but in this UniFi document, in the listed examples, it doesn't mention iPhone 16. So I'm curious to see what I can find out. I need to find out first what type of MLO it supports. Second, whether it works with UniFi AP. I need to capture wireless frames in both 5G and 6G Hz. From the UniFi network controller, I can see for 5G it's using channel 149. So in the Mac Mini, let me choose channel 149, and for channel width 80, start capturing. Then for 6G Hz, channel is 101, and for channel width, let me choose 80 as well, the same as was shown in the network controller. Okay, started. Let me use iPhone 16 to connect to the AP. From iPhone, enable Wi-Fi. Yes, it's automatically connected. Then let me show you the Wi-Fi information. See, it does show a Wi-Fi address, but doesn't tell me whether it's Wi-Fi 7 or Wi-Fi 6E, or whether it's even using MLO. Nothing. But we can find out the needed information in UniFi network controller. You can see for this iPhone client, yes, it is connected to 2 Wi-Fi bands. From the standard, you can see, yes, it does support Wi-Fi 7 MLO. So we got the confirmation. Yes, iPhone 16 works with the UniFi AP. And I have opened the captured frames in the 2 Wireshocks. So the right side is for 6G Hz. We need to find out what's the MLO type supported by iPhone. Let me show you this association request frame, which is sent from iPhone to access point. See under the multi-link information, expand the common info. See, it only shows the MLD capability, and it confirms. It says maximum number of simultaneous links is 1, which means it supports 2 simultaneous links, better than what we saw for the Intel BE200. Right? But it is missing a section talking about whether it supports the EML single radio or EML multi-radio. It doesn't have that section. So I assume it only supports EML SR, not the MR. For the iPhone, there's one interesting thing I want to point out. That's about the MAC address. So from UniFi network controller, if you go to the iPhone, yes, you can find a MAC address here, right? But in the captured frames, you don't see iPhone really use this MAC address to communicate with UniFi AP. Instead, see the right side, the captured frames for 6G Hz. So let's say for the association request or even the 4-way handshakes and then the follow-up actions, they all use a totally different MAC address started with 32. This is not the one shown on network controller. It's also not the one shown on the iPhone Wi-Fi information screen. So it's shown nowhere. But if you check, for example, this association request frame, if you expand to wireless management tagged parameter for multi-link, see the common info section. See, this is the MLD MAC address used by iPhone. This is the exact same one shown on iPhone Wi-Fi information and in UniFi network controller. So the MAC address we see is in fact the MLD MAC address, not the real MAC address used to communicate with individual Wi-Fi bands. Okay, this behavior is different than Windows. Okay, this is the end of the video. Thanks for watching.